Okay, next we have this question. Two concentric circles, center O, A, B, and C are points on the larger circle. Oops, on the larger circle, and D is a point on the smaller circle. ADB is a tangent. Okay, this guy is a tangent to this small circle, and angle BCO, this angle here, is 65 degrees. Show that the two triangles are similar. Okay, straight away. Okay, maybe you need some time, but I hope you can see that this triangle and this triangle, they are similar, and they share this common angle. So I'm gonna use the AA similarity test to show that they are similar, and in this case they share one common angle. So good, we found one angle, but where's our second angle? I can see immediately that there's a 90 degrees over here as well as there, but now I need to argue why they should be 90 degrees. So angle ADO, how do you know it's 90 degrees? ADB is a tangent, O is the center, it goes all the way to a point on the circumference, point D on the circumference, so this OD must be a radius. Tangent and radius, what do you know about tangent and radius? They must be perpendicular, right? Tangent perpendicular to radius. So there we go, we got our first 90 degrees with the reason, tangent perpendicular to radius. How about our second 90 degrees over here? This angle here. How do you know it's 90 degrees? Very simple. You need to zoom out and ignore the small circle. What you realize is that here is center O, which is, oh, by the way, concentric means that they share the same center. That's all you need to know. Oh, it's quite obvious from the diagram as well. Center O, you need to realize that it's actually the center of the big circle. Now ignore the small circle, huh? Center of the big circle, and you notice that there's a point A, there's a point C, which are 2 points on the circumference, and they told you that the okay, did they mention? Let me see. Okay, they didn't really mention, but I'm going to assume that this AOC is a straight line. Okay, which means that a straight line that has 2 points on the circumference and passes through the center, it must be the diameter. It must be the diameter, which means that you have a third point on the circumference of the big circle, then you have to get a 90 degrees, right? Because this AOC is a diameter, and you have 90 degrees inside a right angle triangle. Sorry, there must be a 90-degree triangle that can be formed when you have a diameter as one of the base of that triangle. No? Right angle in a semicircle. Yeah, semicircle, right? You form a semicircle because of diameter. Okay, so that's our second reason. That's the reason for our second right angle over that. So now to present it formally, let's try that. So for part A, how to present it? What I'll do is I'll first draw out the two triangles that are similar first. Label them. Okay, and then I label the angle that should be the same. 90 with 90, this one with this one. First one, angle DAO must be equal to angle BAC. Reason is common angle. Okay, next angle. Okay, I hope you realize it's actually these two angles I'm referring to. Next, I'm going to talk about the 90 degrees. So, angle ADO, it must be equal to 90 degrees. Reason, because of, if you can see from the diagram, tangent perpendicular to radius. Tangent perpendicular to radius. Next, we also know that this 90 degrees is also equal to this angle ABC. So, equals to angle ABC. Now, why is that so? Give a reason. This one is because right angle in a semicircle. Okay, so we got an angle ABC. Good, we found our two angles. Therefore, by the AA similarity test, triangles ADO and triangles ABC, triangle ABC are similar. Okay,